Hello everyone. Today we will be focusing on matrix multiplication. In the past classes we just discussed about the basic operation in matrices and few questions based on it, right? So now we will discuss about how to multiply two matrices. So first of all we must know that if I have a matrix A with the order m cross n, that is it has m rows and n column, and another matrix B. This is my Bij, and let it be A into B, like this is any order. This is the number of rows and this is the number of column. Now AB, the multiplication AB is defined if and only if my n is equal to A. Like, can you observe? M is to n is the order of A, and A is to B multiplied by B is the order of B. So for my AB to be defined, what do I have? What I must have is n must be equal to n. So this is a very important condition. If this condition is not satisfied, then we say that the product is not defined. So if n is not equal to a, we say AB not defined. So let us take a question so that I can explain you better. For example, my C is and D. So these two are the given matrices. Okay. Now, what is the order of my matrix C? It is how many rows? Two rows and three columns, right? So two rows and three columns. And order of D is three rows and two columns. Now just write it side by side. Okay. Now we have to check the last number in the order of C and the first number in the order of the matrix D. They must be same. Then only CD is defined. Why? Because 3 is equal to 3. So yes, the product is defined. So this is the first and foremost, important step. This is the important step to check the order and whether these two values are the same. If these two values are same, we can proceed with multiplication. Okay. So we will first write it side by side. So this is my matrix C and this is my matrix D, right? So the first important step is my first important step is to, in the first matrix which I'm writing, earlier, I have to consider the first row of that matrix, and in my second matrix, I have to consider the first column. Okay. So first of all, let me discuss that whatsoever the resultant will be after multiply. What will be the order of the resultant matrix? So that is also an important question, isn't it? So the order will be, first of all, just write the order side by side. So this was the order of the matrix C. This was the order of the matrix D. Now, since these two values are equal, we will kind of just ignore these two values and equate, and we will just write the resultant, the left numbers, which are left out side by side. So this will be the order of the matrix CD. So what 2 cross 2 means? I will have two rows and two columns. I will have two rows and two columns. Okay. So Now that we are clear with the order, again I will just discuss the how to multiply. So as I said that we have to consider the first row of my matrix C and the first column of my matrix D. So since we know that the order of the resultant matrix will be 2 cross 2 and we need four elements, right? 1, 2, 3, 4. So the question mark where I'm putting, so we will first calculate the first element, in the matrix. How will it be? I will focus on these two, the first row and the first column. I will multiply the first element. This is 1 cross 2. I will put an addition sign. Then what is my next element? Minus 1, minus 1. So this is minus 1 multiplied by minus 1. Then again I will put the addition sign. What is my next element? It is 2 and 5. So I will multiply 2 and 5. What is my resultant? 2 plus of 1 plus of 10. That is 13, isn't it? So I hope so that this step is clear, that I will first focus the first row and first column and I will multiply the corresponding elements and add them as well. So this will give me the first number out here. I will just erase it and write it down. So this, the value which we have just calculated is, so this is my first element. Okay. Now what about my this second element? Now what we will do is focus again on the first row of my matrix C and now we will just pick up the second column of my matrix D. Okay. Now what will it be? I will just write 1 multiplied by the first, the first element of the row 1 and the first element of the column 1 plus the second element is minus of 1 and the second element is 1 again plus the third element is 2 multiplied by minus of 4 because I have a minus 4 here, right? So let us just solve this. This is minus of 2. Okay. So I will just write this value over here. So this is my minus 2. So we are done with the first row of my resultant matrix, in the product. Now we have to focus on the third element. Now what will this be? Okay. So for this, I will have to pick, now since I was left with the second row of my matrix C, I will pick this second row. And again, I will start the whole process again with the first row. I will again pick the first row. What will it be? So what is the first element? It is 0 multiplied by the first element here is 2 plus 3. This is my second element in the row. And this is minus of 1. Minus of 1 in the first column. Plus 4 into 5. So what will it be? 0 minus of 3 plus of 20. This will be 17. So this question mark which I have just written here, that will be 17. So now we are just left with the last element. I will just pick any random color so that it it will be easy for you to understand. Now what this element will be? So again I will just be using the second row of my matrix C. Now I will focus on the second column. So it's like each row of the first matrix is multiplied with the each column of my matrix D. Okay. So I will just write it out here. So the first element is 0 here and my first element of the second column is 7. So 0 into 7 plus 3 into 1. Why? Because the second element is 3 and the second element here is 1. So 3 into 1 plus 4 into minus 4. Why? Because I have 4 and here I have minus of 4. So after solving this, I have minus of 13. Okay. So I will just write my value here. What is it? It is minus of 13. So this is how we have multiplied the matrix and the resultant matrix is this, the product. This is the matrix CD. Yeah, so this is my next question where we have to find the product AB and these two are the given matrices. Okay, so what is the step one is to check whether the order is defined in such a way that my AB is defined or not, right? So what is the order of the A matrix? Can you tell me? It is 2 cross 2, right? And order of my B matrix will be what? It has 2 rows and 3 columns. So what is the next step is to side by side we will just write the given order and we will just check it out whether the last element of the first order and the first element of the second matrix are the same. And we will just ignore these two. So this will be the order of my matrix AB. So this shows that AB is well defined. So I can just proceed with my multiplication process. So I will just write down the matrix side by side so that I can multiply these two matrices. So I will first of all focus on the first row and I will multiply with each column of the second matrix. Now since this is a 2 cross 3 matrix, it means it has 2 rows and 3 columns. So these many spaces I have to fill so that I can find out my matrix AB. So what will be my, so this is what, this is my A11, right? This is my first column and first row. So I will just write A11. What will it be? The first row will be multiplied by my first column. I will write this in a different color so that it is easy for you to understand as well. Just a minute. Yeah, so 6 in, so my A11 will be 6 into 2 plus 9 into 7, which is 75. And what my A12 will be, so this is when I'm multiplying the first row with the second column. My A12 will be 6 into 6 plus 9 into 9, which is 117. Okay. Now if I multiply my first row with the third column, my A13 will be. I hope so that this is clear that this is my A12, this is my A13. What does this signify? This is the first row and this is the second column, like in A12. And what is A13? It is my first row and the third column. So I hope so that there is no issue with the symbolization over, what we are doing here. So now this will be the first row multiplied by the third column, 6 into 0, and this is nothing but 72. So I will first of all fill in my first row in the product. This is 75, this is 117, this is 72. Now we are done with the first row of my matrix. Now in order to write the fill in the second row, what we have to do is now we will have to focus. I will just write it down again so that it will be easy for you to understand. Now we will have to focus on the second row only, and what we will do, we will multiply it once at a time with the each column of my matrix so that we can fill in the second row of my matrix. Okay, so I will just use again different colors so that it is pretty understandable. So what this element is A21 because it is my second row and first column. This is my A22 and this is my A23. So A21 is what I will I get after multiplying 4 plus 21. This is 25. Now let us multiply it with the second column. This is my A22. So this is 2 into 6 plus 3 into 9. It is 12 into 27, which is 39. Okay. Now the last step is multiplied with the third column. This is my 823. This will be, 2 into 0 plus 3 into 8. So this is 0 plus 24. So this is 24. So we will just put these values into the matrix, which, the empty row. The first is 24, 39, 25, 39 and 24. So this is the product, which we have just calculated. So I hope so that the method is clear, that we have to first of all check the order and then just check what is the order of the resultant matrix so that we can just create an empty matrix with spaces like this and we will just find out the value by taking one row at a time of the first matrix and then multiplying it with the column, with each column of my second matrix. Now, another important thing which you can observe is that in the above question, AB was well defined, right? And I even calculated and found the elements. Now, what about BA, right? Why are we calculating, AB always, and why not about ABA? So, what is my order of B and what is my order of A? I will just write it side by side. The order of B was 2 cross 3 and the order of A was 2 cross 2. So now just focus the last element of my first matrix and the first element of my last matrix is 3 equal to 2. No, right? So this means that my AB is not defined. So if any question comes in the exam point of view and you are asked that calculate BA. So rather than just, multiplying it, just check the order and check whether these two values are same, and if they're not same we will just simply say that we cannot multiply, that this operation is not applicable in my matrix. I would like to give you a question that you can try on your home, on your own at your place. So this is a question which I want you to try. The first one is to find AVBA, and the second question that arises is that whether these two value, the product A, B, and B are the equal or not. So just let me know in the comment section. So I will just discuss about this condition that in general, are these two values same or not? So I will just pick up two matrices. This is my matrix A and this is my matrix B. Now what is AB? Now the order is 2 cross 2, 2 cross 2. So I know the last two values are same. So if I will just calculate the resultant matrix will also be 2 cross 2, isn't it? So I will just pick the first row and I will just multiply it each of the column. So this is 1 cross 0 plus 0 multiplied by 1. This is my A11. I'm just writing it, as a one step so that it will not take pages for you to solve this question. Now I will just pick up the second row, the first column I will multiply it with the first column, and this is the with the second column of my matrix. What is this? My AB will come out to be this. Okay, now let us calculate BA. BA will be, now the order has changed, so I will write my BA as this. I will pick up my first row and I will just multiply my consecutive columns in my matrix B. Matrix A, like this is my matrix A now. 0 multiplied by 0 plus 1 into minus of 1, 1 into 1 plus this is 0 into 0. Okay, so what is this value? This will be 0, this will be minus of 1, this will be 1, and this will be 0 as well. So can you just compare these two values? This matrix and this matrix. Are they same? What is the conclusion that we can make? Obviously, this is not same because I have a negative sign here and I have a negative sign here. So it is pretty observable, it is pretty evident that BA is not equal to my AB. So in general conditions, in general matrices, my AB is not necessary that it will be equal to BA. Now, what is this condition called? This condition is called commutativity. Why? Because after I'm commuting my B with A or I'm switching the matrices, the values is not same. So I will say that it does not follows my commutativity law. Okay. So now the next question that must come into your mind is that when will my AB be equal to BA? When is that condition? Now just recall that what diagonal matrices are. My diagonal matrices are in terms of 2 cross 2, what it meant was this is my 2 cross 2. So this was my diagonal element, right? And this is my non-diagonal element, isn't it? So my non-diagonal elements will be 0 always, and I can have any number along my diagonal. So this is my diagonal matrix. Now if I will consider my diagonal matrix A as this and B as this, it is a diagonal matrix, isn't it? The non-diagonal elements are 0 and my diagonal has any numbers as the random numbers. Now what is AB? I will just write my AB. Now this is a well-defined operation because both of them are of the same order. If both of them are of the same order, then AB will be defined. So I will just focus on my first column, then my second column. This is my first column, and this is my second column. What is the value? This is 3, this is 0, this is 0, and this is 8. Now just find out BA. Okay, I'll just write my matrix first B so that you won't get confused. Okay, what is my BA? I'll pick up the first row and multiply with each of the column. Now if we will observe that we will get the same value as the previous one, that is AB. Now you can observe it, right? It is visible that these two values are same. Now if my A and B are diagonal matrix, then AB will always be equal to BA. So why am I telling you this condition is that if in exam you are given diagonal matrix, right? The both of them are diagonal matrix, and if you are asked what is AB and BA, so just find AB. The same answer will be it will be same as your BA. So you don't have to waste your time to calculate BA. You just need to find AB because these two are diagonal matrix. My product will be same as well. Now in general in math, we know that what is that number if I multiply it with a non-zero number, and if my resultant is 0, then what do we imply? It means that my A must be 0 so that the product is giving me 0. So now this concept is not same in matrices. Okay, do not come to this conclusion that if the product AB is 0, that implies my A or B, like both of them must be 0 or A must be 0 or B must be 0. It is not necessary that this has to be the case. For example, I will just give you two matrices. My A is 0, -1, 0, 2, and my B is 3, 5, 0, 0. Now just calculate the AB. What will it be? The first row multiplied by the first column, the first row multiplied by the second column. Now what this value is, it will come out to be 0, 0, isn't it? Now the product is 0, but neither A is 0 nor my B is 0. So just keep in mind that if the product is 0, it does not mean that my matrices have to be 0. Now let us just come and discuss one last question based on my product of matrices. Then we will just end this session. So the last question of this session is we have to find the value of this expression, and my A is this. So now to find this value, we must know what is A square, we know what is A, and what is this value, 6 of I. Now this question will summarize everything. Let it be multiplication, addition. So this will, summarize every concept which we have just did now. Subtraction, and the last thing is scalar multiplication. So this question will focus on everything. So we know that what is my A square? We will just write down the matrix side by side. Now just remember that since we are multiplying A with A, the order will be same, right? This is my 3 cross 3 and this is my 3 cross 3. So the product is well defined and my resultant will also be a 3 cross 3 matrix. So if the order is same, you don't have to check, manually whether the product is defined or not. So I will take the first row. 0 into 2 is it is 0, so 1 into 1. This is my first A11, and then I will just multiply the second. I will just skip this step. Yeah. Then the third column. This will be, the rest will be 0 because we have 0 over here and here. Now the next row, then this is, then the last column. I would prefer that you should do these questions on a paper side by side with me so that it will be easy for you as well to just grasp and understand what I'm telling you. Then consider the third row. Yeah. So I will just write it down. This is 4 plus 1 is 5. This is minus of 1. This is 2. This is 4 plus 2 plus 3. This is a 1 minus of 3. This is 2 plus 3. This is 2 minus of 2. I will just simplify this. 9. This is 0. This is minus of 1. This is 2. This is 5. So this is my matrix, the resultant matrix of A square. Okay. Now we will just substitute the value in the given expression. What is my A square? It is 5. What is my A? And what is my identity matrix there? Now just focus that because we are dealing with 3 cross 3 matrices, my identity matrix also has to be a 3 cross 3 matrix. Now what is my identity? The non-diagonal elements will be 0 and my diagonal elements will be 1. So first of all we will just scalar multiply these two values. I won't be writing this matrix, I'm just putting inverted commas, which means that I'm just carrying this down in my calculation. So 5 into 2 is I will just write it. Yeah, so 5 into 2, this is 0, 5 into 1, 5 into 2, this is 5, 5 into 3, 5 into 1, 5 into minus 1, this is 0. I will take this inside. So this is my matrix. And what is my this matrix? This was my A square. So first of all, we will solve this and the resultant, we will just add this third matrix. So 5 minus of 10, this is minus 1, this is 2 minus of 5. I hope so you remember how we used to subtract. We just subtract the corresponding elements, isn't it? So 9 minus of 10, this is minus 2 minus of 5, this is 5 minus of 15. This is 0 minus of 5, this is minus 1. This is minus of 5, and again if I will put a minus of 5, so this will be plus of 5. This is minus 2. We have to add the resultant to this matrix. What is this? Minus of 4, minus of 5, sorry. Minus of 1, minus of 3, minus of 1, minus of 7. This is minus of 10, this is minus of 5, this is 4, this is 2. Now we will just add the resultant. Now this, with this you can just practice every operation which we have discussed in the last two sessions. This is 6. So this is the resultant. Okay. So what we did was we were given an expression. So this was my expression and we just calculated each and every value and we substituted it back in my expression so that we can find a single concrete answer, the value for this expression. So this is what multiplication is all about. In the coming sessions, we will just focus on transpose and symmetric matrices and what is skew symmetric. So that we will discuss in the upcoming sessions. If you have any doubt, just let me know in the comment section. Thank you.